Hello, and welcome to this panel discussion on Predictive Maintenance Makes a Big Difference as part of our Defining the Smart Manufacturing Journey series sponsored by Rockwell Automation. My name is Katie, and I will be your Global Spec moderator, and I would like to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's webinar. Just to the right of the main presentation window is the speaker bio window with background information on today's presenters. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce our moderator for the Defining the Smart Manufacturing Journey series, Edgar Sauter. Edgar is the Senior Director of New Product Technology at CSA Group. He and his team look at the technology horizon for new developments and applications that could present opportunities for CSA's test, inspection, and certification business. To read more about Edgar or any of our presenters today, please look at the speaker bio window right next to the main presentation window. And with that, I'd like to pass things along to Edgar to lead us through today's discussion. Edgar, welcome to today's event.
Thank you, Katie, for the introduction. I am Edgar Sauter, Senior Director of New Product Technology at the CSA Group, and I will be moderating this panel today. Machines break, and they can be expensive to fix. But the consequences of their downtime can be even more expensive. This is why their maintenance is carefully planned. Smart manufacturing promises to improve even more this process. We have a set of experts today in areas relevant to smart manufacturing that will discuss how is this done and what are the benefits that companies can get in their maintenance from smart manufacturing. So with us today, we have Ryan Kershaw. He is an enterprise account executive with Litmos, an accomplished Industry 4.0 networking vendor. Ryan is also a board member of the Smart Manufacturing and IIoT division of ISA, where he works with the Industry Readiness and Maturity Committee. We also have with us Dean Phillips, who brings 34 years of smart manufacturing experience to this panel. He is an advisor to SME's Smart Manufacturing Advisory Committee. He's an accomplished speaker in IoT, AI, robotics, and AR/VR. He is also an entrepreneur and has served on the board of directors or as an advisor for multiple technical committees. We also have with us Tim Chimbara, who is a Chief Technology Officer for AEMT, the Association for Manufacturing Technology, where he is responsible for industrial research and development, standards, and technology discovery. He has ample experience in the U.S. manufacturing technology, including policy development. And we also have with us George Young, who has more than 30 years experience in plant management and consulting. He specializes in applying digital methods to transform product development, manufacturing, and maintenance performance. He was a founder of Calypso, acquired by Rockwell Automation in 2020, a recognized leader in digital solutions for Industry 4.0. So Dean, Tim, George, and Ryan, thank you very much for being with us today, sharing your knowledge and experience with our audience. So as I said before, smart manufacturing promises to improve the way devices are maintained in the factory floor today, the maintenance of those devices and machines. But how is this achieved? What is the real process to get to that? And what are the benefits that manufacturers can get from smart manufacturing in this area? These are the topics that we're going to discuss today. But before we start, let's have an acknowledgement to our series sponsor. So Rockwell Automation is a global leader in industrial automation and digital transformation solutions. Rockwell's expertise in industrial networks, sensing technologies, and digital software means it is one of the preeminent authorities for everything related to smart manufacturing. For more information, visit rockwellautomation.com. This webinar is hosted by Global Spec, the world's largest online destination for industrial product sourcing and engineering information. So without further delay, let's start with our panel today. And I want to start with a very simple question, something for the benefit of the new people in our audience. And let's start talking about those different definitions and terms related to maintenance. So what is the difference between preventive maintenance, prescriptive maintenance, and predictive maintenance before we jump into the technology? So from our panel, Ryan, I think we were talking about that. So it would be great if you can continue talking about that conversation and help our audience understand those differences.
Sure. No, this is one thing we always talk about with, predictive application or predictive maintenance applications is there's a real gradient in terms of what manufacturers can do with the data that they get from, a lot of their smart manufacturing or IoT systems. And when we talk to people out there, the whole thing is, okay, well, let's jump right into predictive maintenance. Let's go that route. But really what people have to realize is there is, everything from just starting a clock on the machines that you have all the way out to, what we refer to as prescriptive maintenance. So, starting at the beginning, we usually get into reactive maintenance, which is usually oh no, it broke, I have to go fix it. We start looking at condition-based monitoring where we start to look at some of the sensors that are coming out. You can relate this back to your car where high temperature sensor comes on, it's time to bring it into the dealership, get it fixed before something else goes wrong. We can look at, your scheduled-based maintenance, whether this be on a monthly basis, again, going back to the car with the oil change, or we start to look at how often it's being used. And actually, how often it's being used is probably one of the first steps that many people start to take. So in that sort of, to reactive maintenance or prescriptive maintenance, I say, we start to say, rather than going out every 3 months, we'll go out every 2,000 hours to make a change or maintenance on it. And that can have a huge impact with very minimal investment on there. So something to keep in mind. Predictive maintenance is where we start bringing in AI. We start to develop models that will say, okay, as we see certain things happening, this is going to tell us in the next month, next week, next 2 hours, that we need to do this sort of maintenance to be able to make sure that this line keeps running. And then finally, actually, we get a lot of people that kind of say predictive maintenance being the holy grail of this sort of endeavor, but really prescriptive maintenance is the holy grail in this one. Prescriptive maintenance, what it looks to do is kind of take what's being done by predictive maintenance, so taking the models that we build with AI and ML, and to tell you what needs to be fixed, but also to say, okay, well, we know that, or the model can determine to say, here is when you should do your next bit of maintenance on this. Here is the least amount of impact it's going to have on your manufacturing situation. And here are a few things you can do in the meantime, just kind of stretch this out. So maybe you reduce line speed by about 20%, but you get twice the amount of time out of that. And now you can kind of do your maintenance at sort of a lower required point. So you're not having as big of an impact on the business itself. Yeah. So that's sort of the gradient that we look at, starting from the reactive all the way up to prescriptive at the end.
Thank you, Ryan. I was going to actually ask how a manufacturer can create a business case for this, but you kind of mentioned a little bit of what are the benefits of the different kind of maintenance.
So there's two costs to keep in mind. Everybody is very well aware of the direct costs that are involved with doing maintenance. Everybody loves bringing their car in because, they have to pay the oil change place, pay the dealership, the amount of money that they have to pay to get it fixed. But there's also opportunity costs. So opportunity costs have to deal with taking that machine out of operation for a certain amount of time. So, the pain that you get by bringing your car to the dealership, there is the direct cost, which is you paying money to the dealership to get it fixed. But there's also the opportunity cost of you having to sit around the dealership and wait for your car to be fixed. It's the same thing with any machinery that we find in plants is, we have to bring the technician in, but also, well, this is down. We're suffering an opportunity cost, based on the amount of product that we could be putting through this machine to actually make something. So always two things to keep in mind. I think the direct costs are ones that are usually easily identifiable and usually easy or well understood. But if you are making a business case for maintenance and for moving sort of along the gradient towards that prescriptive maintenance, holy grail sort of thing, incorporating opportunity costs into that equation really needs to be done. That we can have a huge impact on the case that you're making for some financial support.
Thank you, Ryan. Now, before we jump into the details of this technology, because it will be interesting to learn, I would like to Tim to help us understand what type of companies can benefit from this technology. Like we're hearing here about downtimes, about machine maintenance, and I mean, to my mind, it comes the huge factory lines and all like the maintenance that have to be done. But for the benefit of our audience, what are those type of organizations that can benefit from this technology, Tim?
Yeah, it's been an interesting trend that we've seen over probably the last 10 years where you almost only heard use cases from larger named companies that we all know. And what we're finding is almost the highest ROI are really the small and medium companies that, can only guess about their productivity. So the trend has been collect data, overall equipment efficiency might be a metric, but really you want to drive to productivity. And I think the biggest gains are where these small and medium companies can start to concatenate their data in their production facilities. So you have overall factory productivity, and the maintenance is a key point. And I love what Mayan hit on. As you start to minimize your downtime, for maintenance or otherwise, particularly maintenance, you also want to maximize your productivity. And that's the nuance that you really need to start to understand. Does it cost, you want to minimize that cost of offline and then maximize the cost of productivity. So for us, the trends have really been small and medium manufacturers who do not necessarily have the time or the tools to go do all this stuff, but those who've been able to partner, and we'll probably get into this a little bit later today, those who've been able to partner, not just with technology, but integrators. I'm glad to hear that Rockwell and Litmus and other folks like that are on this call, because those are really the folks who bring alongside these companies, because the vernacular and the approach is not always straightforward.
Thank you, Tim. Okay, so this is very interesting. Now we are seeing how companies can benefit from this, but let's now understand the technology itself. And I think we can separate it into two big components, which is hardware and the software piece. And I would like to start with the hardware piece. What type of devices can be kind of monitor, and what are the devices that we can use to monitor them? And let's start with what kind of devices can be monitored. What are those devices that need to be monitored? And I don't know who in the panel would like to jump into that to answer that question. But if I am a manufacturer, what are those machines that would be more interesting to start monitoring?
Yeah, I can take that one. Yeah, I've got way too much background in sensors and automation. The nice thing now is that, with the technology that's out there, just about anything can be measured. It does come down to cost. How much do you want to spend to make this measurement? But, the hardware that's available out there, just can do any application. I mean, we look at, vibration always being a big one. And we see ones that are, these little monitors that are the size of a pack of cards that get bolted onto the side of a motor. And now all of a sudden you have intelligence out there and it's streaming out to your system. We see optical methods now that are able to start doing, start looking at oils within the machines that can do measurements based off of that, see how that's changing. Even simpler sensors, conductivity can be used in there. So there's a lot of different ways that we can make those measurements. It really comes down to the actual application that's being monitored. But, it is something to consider about, how much money do you want to put into there? But if the application is big, it's one where, funds might not be an issue on there. We used to work for one of the companies I worked at was dealing with water quality issues. And really, if the system, failed, it would essentially shut down the plant. And it was always when we had, the $1,000 conductivity sensor that'd be at the end of the line, it would fail. And we get a panicked call from some company out there saying, we need this as soon as possible. Our entire factory shut down. And said, well, where's your spare? Oh no, well, we're a lean shop. We don't use spare. We have to have this right now. So, okay. So it's always something to consider when we're looking at that. But yeah, it's something to definitely have a look at. The other nice thing with the new technology is we're actually seeing a lot of these sensors bring on their own predictive maintenance algorithm. So, to Tim's point, we're starting to see a lot of this pick up at the small and medium-sized businesses. And I think a lot of that has to do with some of the smarts that's being put onto the sensors themselves. So we see analytic sensors that now tell you, here's what I need to be calibrated. and I'm going to last for another year in this specific application before I fail it and you have to replace it. So I think the intelligence is coming down to the end of the line where, some of this more advanced stuff can actually be done by smaller companies without the big effort.
Right. And now, Dean, a quick question for you. I know your background in IoT as well. Is there anything that manufacturers can do if their device is not doesn't have embedded sensors in them to capture that information?
Yeah, there's a lot of standalone types of sensors that you can use to do everything from vibration. As Ryan had mentioned, there's more technology now for sensing all different types of things. Vibration. You think about what's in your phone. If you think about what's in there, there's positional sensors for GPS. You have sensors for vibration. It can register all different types of temperature. Are add-ons now. Smartwatches. They have micro sensors that you can apply in a lot of different ways. And one of the things that I really like that Ryan had mentioned, and I was going to bring up myself, which is a lot of them come with their own algorithms, but the other half of that too is they have built-in calibration mechanisms within them also. So you don't have to necessarily calibrate these sensors either. So a lot of these smarter sensors can do so much more than we used to be able to do with them. It would be hours in some cases. If you take a look at something like a chemical factory, which makes steel, okay, you have to bring up the materials, and so you're not just balancing the different amounts of different chemicals that go into making the steel, but you're also balancing the temperatures as you bring them up. You have to balance all of this in order to get that temperature up. And different sensors, to have that kind of algorithm to tell us what we're looking for and to understand what kind of output we're looking to get, can be so much more of a help when we start looking at predictive and prescriptive down the road. Think about how much predictive information you need in order to do something. Now, when I go and I want to know when that failure rate is, I can at least look at what that is, because those are harsh environments when you start looking at those. I can start to track when things are going to start failing in my machine. Vibration is a great indicator of failures, but also motors. A lot of companies now are doing motor sensors, so I can tell when things are starting to get out. So not only the vibration, but current starts to go up, how much current draw I have. And if it's not drawing more current, why is it not all of a sudden, if I'm not having, there's probably something else going on, talking about things like viscosity of oils and things like that. As those go down, as the viscosity of the oil goes down, the motor is going to go down, the current draw is going to go down with it because the oil's thinning out. So there are other aspects of that go hand in hand. It isn't just one sensor. It's all these other sensors that marry together. That in and of itself gives us a lot bigger picture.
Good. Now, I have a couple of questions after that, but I want to then move to George, because what you said is very interesting there on the amount of sensors, the number of sensors that I need. You said there's more than one. So how do I deal with all the data coming from those sensors? How I transform that data in actionable information?
Yeah.
George, you could help us with that. That would be great.
Yeah. Well, so the first thing I'd like to point out is what other people have said, which is that you don't necessarily need to over-censor a problem. What you want to do, we always say, let's define the problem. Let's define the thing you're trying to optimize, whether it's runtime, downtime, throughput, whatever it is. It's at the end of the day, you're setting up an analytics problem, and you want to optimize that. And you want to use the resources that are at your disposal. Cameras are a really interesting resource because you can get a lot of information from them without buying sensors. So one of the, I would say, mistakes I see some of our clients make is that they invest a whole bunch of money in adding lots of sensors to something when maybe they didn't need to. So if you have motors and drives, some simple vibration sensors, some cameras, we always start with let's define the problem first, not spend too much money on the capital side with the sensors, because the really cool thing about predictive maintenance and about all the things we're going to talk about today is essentially advanced math. And math is a zero capital investment. So that's what we're trying to do, is we're trying to define the problems, learn more about it, take a descriptive set of data and make a predictive set of data. Then if we can do that, refine the model further, and as we heard from Ryan at the beginning, develop a prescriptive set of data. And then, technically speaking, you can advance to the next step, which is autonomous automation. That's kind of the goal of Rockwell, is to try to drive our clients through that cycle from descriptive analytics to predictive to prescriptive, and then eventually try to drive autonomous automation. So the first thing is don't over-censor. Let's look at the data. We can use, now how to use the data is interesting, because you can think about analytics happening at 3 different layers in a plant. There's analytics that can be done at a control layer. So if you ever want to get into autonomous automation, you kind of have to have, you have to eventually get to the models that you can program in at the control layer. You have, you can use business warehouses and data warehouses at a plant layer to build the algorithms that you're then going to test whether it's a particular piece of equipment or in a process. And then you can also use enterprise applications as well. I think the one thing I would talk to the folks in the audience about here is that if you want rapid response and you really want to drive autonomous automation, your best, you're going to have to do it at the control layer. So you can do the analysis at all of those 3 different layers, but if you really want to get through the full life cycle, you're going to have to do it at the control layer. And in my experience, there's some misinformation out there about, magical methods of predictive maintenance.
Like what?
Well,
Edgar.
Go ahead, Tim.
You fish your thought there, George. No, I like where you're going. Keep going, George.
Well, it's just that, we put everything in the cloud. It's all about the cloud. And you put it in the cloud and then everything's perfect. And that's not true. I mean, full stop. Sorry. Yes, go to the cloud. The cloud is great. A lot of this unlock is because we have advanced computing power, which is enabled by the cloud. But simply putting data in the cloud without defining your data models and things like that and setting up the problem, there's people who have been disappointed. If you set up the problem right, predictive maintenance, this area that we're talking about, is one of the truly low-hanging fruits in the future of digital manufacturing.
Thank you, George. Go ahead, Tim. Do you want to add something there?
Yeah, I think it's critical what George just talked about being, math at the end of the day. And for the audience, to sometimes when we get frustrated as either operators or managers, it's because we had expectations that weren't met. When people talk about data science and all these great tools, you have your data part that George started getting into with the information modeling, semantic dictionaries, basically your data engineering side. And then you have your statistics side, and then you have, which is the math part. And then you have your coding. I want to make this, a little bit more scalable, a little more efficient in doing it. And then you have your tool set that everybody wants to quickly jump to, the AI and the ML and all the other subsets. At the end of the day, as you start to collect this, the reason I love this predictive to prescriptive maintenance topic is that the math will help you classify and cluster and run statistics on all this stuff that will give you priorities and take some of this first order stuff off the table real quick. And then you have an engineering statistical problem, which is much more manageable than, I don't know what's happening in my factory, and I love what George said, just throw it to the cloud and it's going to work. And when it doesn't work, which will be 99.99% of the time if you don't define it well, you're just frustrated. You walk away and you think, because this ML AI stuff is just, it's a bunch of hooky. And it's like, well, no, you just got to look under the hood. It's It's applied math in a very intentional way, and you can extrapolate out of that like any engineer would good things. I think it's just good for the audience to kind of level set a little bit on that.
If I could piggyback onto that quickly, I think that not only does it help you need to have actual at the piece of equipment understanding of what's happening. This shouldn't replace lean or whatever your process is, because you need to understand those processes in order to start with a basis of what I'm trying to achieve. If you don't, as George had mentioned, you need to understand what you're trying to analyze. What is it what do I want to achieve at the end of the day? What is it? And you have to be able to do that. And then you can start balancing your weighted, whether it's a calculation or whatever. Everything you can measure everything, but not everything has the same value to it. Vibration is a great high-ranking value to it, because when problems start to occur, vibration starts to follow along with that. Temperature, a great failure indicator is temperature. So those have a little bit higher balance within that weighted algorithm that you're going to define. That you have to be able to know that, though. You can't just think, well, I'm just going to turn this on, it's going to go up to the cloud, and I'm not going to have to do anything. There's more to it than that. I'm not saying that you can't have a very simplistic model to start, because I think you do. The simpler, the better. That starts you moving in that direction. But then you have to have more advanced things to say, well, I changed jobs here. I'm not just doing this job where I'm manufacturing, machining, or stamping this part, whatever it is. I'm not just doing that job. Now, when I switch to this other job, that led to the problem. So you have to be able to balance in these other information that starts getting pulled in. And that's where the true value, I feel, gets unlocked in the AI aspect.
Thank you. Yeah, go ahead. Sorry.
I was just going to say on Dean's point, like when we talk about adding weights to maintenance and that, and we can tie this back to what we saw in alarm management standards. So, I mean, one of the big things to always watch out for is alarm management came out of the whole thing of, hey, sensors are great, sensors are everywhere. Let's just alarm everything. We'll measure everything and alarm everything. And we ran into problems where alarms would start getting ignored, or we'd have nuisance alarms, or operators would just
worse. People didn't pay attention to anything.
Yeah. So I mean, coming up with a standard or some sort of weighting to say, okay, you've got 20 maintenance tasks. Here's the one that needs to be done now. The rest can be done, following along. I think we have to consider about when we start to get into these advanced topics of, okay, we can now start really getting into a lot of the maintenance items on there. We know that if something's broken down, it's going to go top of the list. We need to give the operators a way to kind of handle that without getting overwhelmed by the amount of information that's coming in. So something to always consider. And like I said, I mean, we look at alarm management, it's kind of a template for that. And I think, as Dean mentioned, just providing weighting on that, I think be a huge advantage.
A hierarchy of those, absolutely.
Now, let's round the topic a little bit for people who don't have any sort of smart manufacturing now, or predictive maintenance now, or prescriptive. I am a manufacturer new to this. I know in my process what are those machines that are critical to my process. I know the inputs, the outputs, and I know how they break. How do I start if I want to kind of transition to predictive or even prescriptive maintenance? Do I just put sensors everywhere and then start eliminating, or do I what's the process? You are the experts, so tell me.
Personally, I would start with a current clamp and an hour meter. I mean, that's probably your greatest way to go, because now you can get away from doing I got to go out there every week or every month and do maintenance, to I'll go out there every 3,000 hours and do maintenance on it. And we usually see that as step one of let's just monitor how long this is actually on for, and then we'll go out and maintain it. So I mean, I think that's a good step one on there.
I would argue with that one little bit. I've had companies actually that took that approach, and they had 80 machines, and they were going to have somebody go around with an hour meter and track how much that machine ran every hour. And I said, what if it's not supposed to run? What if it's not scheduled to run? And they were gathering data that was completely useless to them because they didn't understand their process well enough to be able to, and they were tracking it every hour, how many minutes and seconds it was running for that hour. And if it wasn't running, why was it not running? So they didn't have a good feedback loop on that. But it is as simple as that, but it does have to be defined a little bit better than just saying, just go out there with an hour meter and a clamp on amp meter. It can be that simple, but in many cases that may lead you in the wrong direction. You may say, I've got a lot of problems on this machine because it's down for 8 hours a day. Well, it wasn't scheduled.
Yeah, no, yeah, and I think you're right. Yeah, to just have somebody try to design kind of a model to say, okay, this is how long it usually gets running for, it's going to fail after, fairly quickly. I think you'd have to have some sort of permanently attached meter with like either a set of numbers or even a Christmas tree light saying, hey, come take a look at me and let's get this fixed up. But yeah, I mean, just putting that model together, not going to last long. Yeah.
The approach that we use is, basically a business case approach, and we are going to look at two dimensions, which is the business impact, which could be throughput, higher throughput, or reduced cost. And on that, by the way, one thing that I don't know that I heard explicitly stated is that it's not just the cost of the equipment, but it's and critical spares that you might have. You have inventory and things like that, but it's also people that you have that are kind of waiting around for things to break. And if you have more predictive models, you don't have as much of that. But so anyway, two dimensions. One dimension is the kind of the financial. The second one is the problem definition, which is what are our chances based on what sensors are in place and what we know about the process, the quality of data, things like that. Which ones are most likely to be successful? And it's, again, I want to come back to it again. I'll say it over and over again. Problem definition is critical because when you get into a plant, you have some crusty veterans who are a little bit suspicious of these kinds of things, and you want to have success. So business impact and maximize your chance of success. If you do that, then you get a pull. You get the people believing, and they adopt it, and this becomes a way of life. It becomes part of your preventive maintenance program.
Edgar, one of the things. Oh, go ahead, Dean.
I was just going to echo one thing that George had mentioned there is when most companies look at this IoT, the problem or the disconnect that we typically have is that when they're doing their math, it's their assets that they're tracking a lot of times is time cards from personnel. How is that person allocated? Are they being maximized to their efficiency? And they're worried about, well, that person's standing around. And that's a very good point about one of the challenges of IoT tends to be physical machines, whereas most companies track hours and time like that. And that can be one of the things that's very difficult to match up together because now you got to reallocate your staff. So, I'm sorry, Tim, please.
Yeah, no, that's actually a really good point. I mean, 30 seconds just on that, Dean, is we're starting to see sophistication at that process work instruction level, mapping it to an NC line of code at a given time, overlay the synchronization and going, okay, now what happened? But what I wanted to tag on also, Edgar, to sort of round out my comments assume people have well defined their problem and have a more business approach. But the tactical step that we have seen wearing my NT Connect Institute hat, and I know Ryan with ISA, we've seen many ISA 95 implementations with NT Connect and some other standards groups, but the lightweightness, if you will, of an NT Connect approach with that standard is it allows you, it's free and open, it allows you to just pull data as is through the agent, so you don't have to worry about your information modeling, and then just publish into an Excel spreadsheet or even HTML using current protocols. So the reason I say this, Edgar, and all these documents are online and in places like GitHub, the talent, this doesn't speak to 100% of the talent in factories, but many of the new talent or even the up to 10-year talent understand a bit about GitHub, and that's to our benefit. It doesn't solve all. Now, there's still those who are not that familiar with the GitHub approach and would struggle. That's why this almost 3 or 4 step use case for an MT Connect implementation does allow you to get some data, see it in a spreadsheet, publish it on your intranet or even on your local PC just as an HTML file. And it's all, I say all of this to say you're visualizing your first step. You just that this thing can happen and that there is a possibility to do this IIoT thing is almost half the battle. Just getting someone through that process, and it really is a 30-second process. It's like, oh, okay, I say 30 seconds means you've already collected the data. But, this is half the battle. Is just getting folks to understand there is a way forward and there are things you can do. It doesn't solve everything, but just having that confidence of first visualizing some data, even though it's just cells in a spreadsheet coming off a machine, pretty positive and it's pretty enabling.
Yeah, thank you, Tim. Now that I have you here, I would like to ask you also about context, which was a comment that I believe you made in a previous conversation. We were talking about this topic. What is the importance also of taking context into account when we are collecting the data for predictive maintenance?
Yeah, that's squarely in the information model world of the semantic dictionary. And any data point we get without a label classification it's not useless, it's just not ready yet. So you really need to understand what that data you just collected is and how it fits in the whole world of either your equipment, your process, your factory. And the better you can align that data point to its role in that process, the closer you're going to be to understand the prescriptive nature, in this case, prescriptive nature of maintenance and what's required. But without that context, and this is why I really am a fan of, I'll call it, the AI umbrella of tool sets and technologies, but machine learning particularly. When you look at the regression analysis you can do to understand useful life, when you can add clustering, k-means or otherwise, when you can start to do classification models and approaches, this is where all that data that would have otherwise been unidentified becomes more informative. And I think that's really why I love these technologies, and it's going to help us understand better what's happening within the factory, because you can name it and claim it almost, if you will, to see, okay, these data do have a role and it fits in this kind of category, and therefore it means this to me.
Thank you, Tim. Now, I want to jump a little bit in a previous comment that George made about the cloud, because let's say that I already allocated cost for my sensors, for the devices. I put it there. I'm collecting the data. Now I have to analyze it. And the truth is that the cloud has actually reduced operation cost for many companies out there. Right? They are being able to kind of share that resource. Now I have to think on the second step of this process, which is analyze that information. Do I have to acquire my own processing power? Do I need to even bring on board data scientists to achieve a good result? Is there a way where I can kind of reduce my cost when it comes then to analyze that data and get actionable information?
Well, I guess I'll go first here. You the first thing to do is to try it out and see, because the thing is that one of the questions is whether you want to have the analytic capability in-house or you're comfortable kind of paying for it. And a lot of our clients do both. So they'll have a certain group inside that can do it, and then if they need extra resources, they'll go externally. I think any company that's serious about digital manufacturing is going to need to build the in-house capability, hire the data scientists, and get comfortable. The other thing, too, to reduce cost is that a lot of things, there are publicly available algorithms and literally free libraries of things that you can access for simple and frequently encountered maintenance use cases. And then if you get kind of experienced with it and you're beginning to do your analyses, your data scientists and your large cloud database, once you've got the data properly cataloged and tagged, you can begin to crunch the numbers, begin to look for relationships, and begin to look for system-level dependencies, which then ultimately could bring back to program at the control layer. So again, I'll go back to that one answer that I used. There's really 3 layers: control, data warehouse layer, and then an enterprise cloud layer. All those things should be optimal. And it's up to you to decide what do you want, what capability do you want in-house, and what are you comfortable relying on outside resources.
Thank you, George. Now, do you think, and this is a question for all of you, I don't know who would like to answer it, that we will get to the point where machines will tell you exactly when they are going to fail, and they may even order the replacement, the device that need to be fixed, and then there will be a robot that will fix it, and voila, everything is ready. And how far are we from that, really?
So, I mean, I think I'd go a step further than that, and I'd say that not only will the machine have, the part or tell you what's wrong with it and, tell you what you need to order. I mean, I think one of the nice things with IoT is its ability to connect throughout much of the enterprise. I mean, I think you get to a point where, all of a sudden a part will show up one day and it'll say, install me now before the machine fails. The machine will have actually gone through, it'll shipped in. I mean, we're talking to a company that's looking at doing something like that, where they're looking to reach into kind of their customers and make sure that parts are moving before they need to get there. So I think that's really moving along. As to the when, I think in many simple applications, it's not too difficult. You really just need to identify with a pretty high certainty when something is going to fail. We see this again, my own company with pH sensors. We could provide down to the day sort of level. Mark that back to the ERP system, have the ERP put a simple rule that says whatever gets below 10 days, put a new order in. That can all be done automatically at this point with current technology. So, I think that's not too far away, and especially for the simpler applications, I don't see that being a big issue. For some of the more difficult ones, then you have to develop really the prescriptive maintenance, and then that becomes the driver. Everything after that is just connect the dots and make sure the part flows as needed.
Now, and how is...
I'd say there are examples now. There are simple examples of that happening now. And there are a lot one of the earlier points that a person made, if you look at OEMs, if you look at people that make pumps and compressors and things like that, one of the ways, we talked about cost reduction and labor reduction, but one of the things you should pay attention to is competitive advantage. Because if your pump or your compressor has intelligence built in and tells the person, we're looking at 2 weeks worth of life, I've gone ahead and ordered the part, it's being shipped. We have done that with an oil and gas company that runs lots of remote wells, like out in West Texas, and you got guys driving around in F-150s. The parts come to a central distribution thing, they pick them up and they go install them proactively. So I'd say it's happening now. The simple cases are here.
That's interesting. Now, would that information also help manufacturers to make better products as well?
I would say that that's certainly the case. What we're seeing already now is people using data to improve their processes within the house. Take a look at how you currently handle your material. So your raw material, you have some type of a system for managing your materials. So as your materials are flowing through your plant, the minute it leaves the stock room, it now becomes WIP, work in progress. So now that it's work in progress, understanding how that's going to be processed through and where it's going. If you know that this equipment is going to be down for maintenance, because as we all agreed there, is that if we can predict when that's going to be down and schedule the part coming in, I know now when I'm going to have to allocate doing that work, and I can schedule that in advance. So now I can rework where things have to go in my production numbers. So my production can also handle that, and also it can also allocate now personnel, because now I don't want Joe over here to be working on this machine on Tuesday because we're going to put that new pump in on Tuesday because we already ordered it. It's already, all of those things have to start communicating with each other better to achieve this. I don't want to say utopian view because I think it is a realistic view, but the problem is when you start getting all these systems talking to each other, that becomes more of the challenge of, are they all communicating? There's that old saying that the illusion of communication is that it's happening. And I think we're challenged by that certainly when it comes into technology, is we think we can communicate between systems. And as Tim had mentioned earlier, sometimes it's just getting the timing even.
Thank you, Dan. Well, this is an excellent topic. We could actually continue talking about this for another hour, but unfortunately our time is up. It's over. So thank you for the excellent conversation. Now it's time to invite our audience with some questions that they are already coming, and we will answer it shortly. In the meantime, let's have a quick break and pass it to Katie. Katie, back to you.
Thank you all so much for that great presentation. As Edgar mentioned, we are going to move into the question and answer session. If you have a question for us today, please go ahead and enter it into the Q&A window and hit submit. We will get to as many questions as we can today. If we do not have time for your question, do not worry. We will reach out to you following today's session. Edgar, I'm going to pass it back to you and the group to answer some of our attendees' questions.
Thank you, Katie. So we have some questions from our audience. We hope to answer now in our conversation. So the first question says, can you give us some real-life use cases from your experiences or profession?
I could take that one, Edgar.
Thank you, Dean. Go ahead.
I've got a couple of instances. There's two manufacturers in the appliance world that use are currently working through IoT and using sensors in their applications. The biggest gains that they see in general is right away that they get a better understanding of their process, and they start to understand, I think, productivity numbers a little bit better. If you ask somebody what their OEE numbers are, they will give you this pie in the sky. Oh, we're probably at 90%. I can assure you, you're probably not at 90% in the stamping world. It's definitely not happening. And in machining and other things, you're not taking into account the true information. So as long as you're open to understanding that you're not at that, you can start making strides to move forward. In the automotive industry, yes, they have moved to getting 5-minute changeovers. How do you do that? It's not one thing. It's multiple things, and being committed to the time improvements that you're gaining by using these sensors. You're using all different kinds of sensors, whether it's as simple as a proc switch to as complicated as an analog sensor for temperature and vibration, or all the way up to even more advanced sensors that you can go to. But it's taking ownership of that that's really important, that the group, it can't just be one person and say, well, go to see so-and-so for that, how it's running. No, because the problem is when so-and-so leaves, that whole project goes away and everybody goes back to doing what they used to do. So you have to have a company-wide ownership plan. And then that can allow you to get to a very specific goals. And we've seen people improve their safety records, as simple as something like that, by using AI along with IoT. So there are lots of improvements, but you have to take ownership when you're moving forward, because without it, you're going to have a very difficult time in the long term.
Thank you, Dean. The following question says, what are the use cases with the highest return on investment?
Yeah, so this one's an interesting question. It's probably the most frequently asked question I get. It's also an impossible one right off the top of your head to answer, because there are certainly use cases that we encounter frequently. But as I mentioned earlier during the seminar, you want to understand the problem. You want to understand what are the predictive and preventive maintenance use cases that have the most value for the client, and simultaneously, by analyzing the problem and looking at the data and the sensors and things like that, you have the best chance of success of solving. Because you want to have a nice success, a bite-sized problem where you can show success so that you can get the people on the management team, people at the plant on board. That helps to also drive adoption. So as a rule of thumb, we look for things that reduce cost, either from a critical piece of equipment or from having lots of people kind of on hand that we're trying to manage the scheduling. That would be one thing where I would look, and I'd first build my descriptive model, and then I want to go through the life cycle of analytics. I want to take that descriptive model and build a prescriptive model that I can demonstrate, and then I want to move, to the next step to go from predictive to prescriptive. So that's what we like to do. High value, good chance of success, and something that illustrates the life cycle from descriptive to predictive to prescriptive.
Perfect. Thank you, George. The next question says, what are some examples of how to drive adoption?
Yeah, I'll take that one. I mean, whenever we're looking at sort of a new process being implemented, especially in the automation side of things, we always consider the trifecta, right? People, process, technology. Technology being probably the least important out of these three, but still extremely important. I mean, make sure that you have the right technology, not too little, not too much. Make sure that you've got your base infrastructure in there. Process is probably just ahead of that. Make sure that you have the right data gathering methods, contextualize the data that's coming in, standardize, normalize, make sure that all goes smoothly. We also talked a little bit about alarm management, taking those principles and applying them to maintenance applications, waiting things out so that you're not blowing up the entire organization with all this new data and all these new tasks that they need to have coming in. And then last but not least is always the people. It's the most important part. This is the part that's going to be running it, whether it's the guys on the shop floor or those in engineering that are going to design, maintain the system, data engineers, data scientists. Make sure you have the right people in place. Definitely work on change management topics, being able to introduce the long-term vision of the project, why everything is so important, and then work with them as they kind of get into the highs and the lows of every sort of project. As you implement, there's the I call it the ditch of despair. As you get past that first stage, you start encountering troubles. It's always the worst part, but if you can get through that, you're good to go. So, I mean, having the right tech, having the right process to go along with that, and then having the right people and supporting them properly, those are your biggest three for adoption.
Fantastic. Thank you, Ryan. Well, we have one more question here for today. It says, what are the advantages of predictive maintenance versus preventive maintenance?
Yeah, I'll take that, Edgar. And, this is a little bit of some of the understanding of the machine learning data science tools as well. And one of the things that I have seen and we have seen as an industry is the predictive, for all the reasons you already talked about today, it's a bit constrained. You're still, it's still better than preventative, but we really want to get to that prescriptive. We really want to have an opportunity where just the right amount is done at just the right time and for certain applications. So, the advantage certainly with the tool set that the AI and ML and that tool suite will give us is better understanding of the data. So therefore the data has better meaning. And the reason I want to say that phrase is there's also other applications where the contracting based on maintenance is being improved by use of this data science tool. So if you have a contract, a warranty that states it needs to be maintained by some percentage, and again, most of those are very preventative. It's based on time and duration, not actual reality and not usage, not this other stuff. So if there's a way that the data methods and tools can start to better contextualize data coming off the machine or the process as a way to better inform a contract, let's use some blockchain language here, because I do like this use case for blockchain is a smart contract. So we now have indisputable third-party data that validates certain things did occur in maintenance land on my machine or in my factory. Therefore, me, the OEM or the integrator provider, will assume certain things are fine. And it doesn't have to go to pointing fingers. It certainly can go to paying, just like you think about on the commercials for insurance in your car. If your car is telling your insurance provider how well you're driving your car, your rates tend to go down in some cases. same kind of deal here. If you're maintaining your equipment well, and with these tools and techniques that AI and ML are starting to enable us to have, I think we're going to see smarter contracting. We're going to move away from this just predictive maintenance into this prescriptive maintenance. And I'm going to go even further and say into a better relationship for warranties and other contracts as it regards maintenance.
Thank you, Tim. Well, Dean, Tim, George, and Ryan, thank you very much for being here with us. This concludes our session today. We appreciate your time sharing with our audience your ideas and your experience. To our audience, thank you very much for the questions and for being here listening to our experts. And this, just keep in mind that this panel can be accessed at any time online. To Rockwell Automation, thank you for the staff of experts that are making smart manufacturing a reality. Finally, for Global Spec, thank you to the millions of technical professionals, engineers who have allowed us to connect them to the parts and services they need for project success. So now, Katie, back to you.
Thank you, Edgar. Now, just a few items before we end things today. I would like to say a huge thank you to all of the panelists today and to Edgar for leading our discussion. And a special thank you to Rockwell Automation for sponsoring this Defining the Smart Manufacturing Journey series. Today was session 4 of our 4-part series, but don't worry, all the sessions are available for the on-demand period. Please join us for the rest of our sessions. You can visit our series page using the link listed in the resource widget. Sign up for all the sessions today. You won't want to miss it. And one last thank you to our audience members for being here with all of us today. You will be receiving an email from us with a link to the on-demand version of this presentation. You will be able to come back and watch this again or even share it with colleagues. Again, thank you for taking time to attend this Global Spec series. Take care, and we will speak with you soon.